going to get them to enter, the user to enter 2 numbers. So I'm going to put in my name again. I'm going to enter 2 numbers. I'm going to say 1 and I'm going to say 5. So we can get them to enter numbers. So they also printed them out. So I'm going to do that one more time, but with a print. We're going to add number 1 and number 2 together. And say 1 and 2 is, it's hopefully going to be 3, right? No, it's actually 12, because the thing is, when we take input, it always is as a string. It's like, oh, you entered this series of letters, numbers, or symbols. I'll keep that as letters, numbers, or symbols. It just happens that we've only entered number symbols here, but it doesn't know that, because computers, my hot tip is they're not very smart. So we need to teach them everything that we want them to do. So we can see what the difference is if we use something called repr, which is a little known secret. So I'm going to do repr, which is representation. So this is the Python representation of our numbers and our name. So I'll print those out so we can have a look at what they look like. We'll enter all our stuff again. Okay, so we've got Renee as a string, as we want, and 1 is not a string. It is a string, but we would like it to not be a string. And we can see what kind of data it is if we go type. So we're going to say type. We're going to enter our data again. We're going to say 1 and 2, and we've got both of these are strings. So that's not useful for us currently. But we can change that over. So what we can do is something called int, because the thing that we want is an integer. So we want to turn this into an integer. So we could, let's jump back to here for a second. So we could say a equals 5, and then, well, no, we want to say a equals 5. And then if we wanted to say it was actually going to be a number, we could say int a and reassign that to the same variable. So we could say, okay, that's what we're going to have here. Override it. We don't want that string version of it. Get it out of here. And then we're going to print out a. Let's print out a plus something. So we'll do a plus 5. No, a plus 6, just so they're different numbers. Hopefully it's going to be 11. What do we get? It is 11, because this is now an integer. So we jump back to our input, and we can say, okay, we've currently got input a thing. But what we want to do is we want to turn this whole thing into an integer. So we could do the same thing we did on the last example, where we got number 1 and then we overrode it with a new integerized version. But actually, just off the bat, we're going to turn it into an integer. So I'm going to wrap the whole thing. So whatever you get from the input, put it straight into this int function and turn it into a number. Now let's do the same here. So let's run that. And I should have got rid of this name part, because I keep having to write in my name. So we can now see that number, when we printed out the type of number 1, it is now an integer. And we can see that 1 plus 2 is now 3, not 12, in fact, which is super handy. So that is, yeah, a great thing to be able to do. If you can convert integers to strings using stir, like we did on the previous example where we wanted to add them together so we could print it out. You can convert your input strings into ints, or we could also turn them into floats if we wanted to be able to enter non-integer numbers. So let's run that again. Let's get rid of this. I don't want these name bits anymore. Float. Okay, we run that. I'm going to say 4.545 and 23. We get what those are added together, and we get the type float, which is our non-integer numbers. So there's lots of other kinds of data that you can put into variables. Obviously, you can only enter strings via the input, but we have heaps of other kinds of data, which we'll cover in coming weeks. We saw you can make a copy of something. Oh, we've got one more example I'll do before we finish up. So I'm going to do it in my notebook here. One more. Okay, so we've got A equals 56. We've got B equals A, and then we've got C equals 5. I want people to guess in the chat. Oh, I've got a question from Sarah as well. I want you to guess. No, this is A equals 5. What is in A and what is in B? I'd love to know what your thoughts are on what's going to be in those before I print out A and B. Anybody got a guess for me in the chat? Oh, Jack would love to have a guess, I reckon. Or Sarah, she could have a guess too. Or our host, Sarah. She's following along. No guesses from the chat. Look at my chat buds hanging out. Okay, well, we will. I'll get to Sarah's question first. What happens if you use int when it isn't a number? It's going to be mad. Is what's going to happen. So let's jump back while we have people enter something in the chat. We've got people helping out in the chat. A is 5 and B is 56. Excellent. I love that one. Excellent. Okay, that is in fact Haritana Ravaka. Very excellent work there. We do get 5 and 56, which I'll cover why in a second. But there's some interesting cases, not with strings or numbers, that things might be a little bit different. So let's jump back to our other code and let's run this again. And let's not put in a number. We'll write, my favorite number is Renee, and there we go. Could not convert string to float Renee because it looks to make sure that it has all the right things. I.e. it needs to all be numbers, so it takes care of it for you. And we'll run this and do it with int. So let's try, we're entering a number, but it's not in fact an integer, and could not convert the literal for int of base 10. So this is not a base 10 integer. So if something isn't the correct format, then it's like, no, I'm not doing that for you. I'm just going to break instead. So there's useful ways to try and flag this. If you're working with this kind of input in your code to make sure that it does not break everything. But that is a more advanced topic that we'll cover, a couple months down the line. We'll work with try and accept if you are hanging out for that. Do make requests of what you want to see in coming months. Oh, thank you, Manoy. Renee, wow, you were amazing. It's the first time for me to understand coding without difficulty. I'm so glad for being part of Playing with Python from episode 1. I'm so glad you're here too. And I hope to see you next week because, we're going to be doing more stuff like this because, coding can just be really scary when you didn't have someone there to tell you what parts are important to have a look at first because there's so much stuff to coding, but actually you can do a lot of stuff with just a few bits and pieces. So, do come along for the journey. So let's wrap up with this. We've just did making a copy of a variable. So we said A is this, B is equal to A. So it's just going to make a copy of this little orb, our little blue number orb. And then we're going to say A is something else. Let's say it's -5. And then we've got a separate item of those. So we had our different kinds of data. We had our strings and our numbers. I've colored them like different blue and green orbs. They have different things that they can do. Like we saw that you could do particular kinds of things with strings. For instance, you could say car in carpet, but if you try to say is car in the number 5, it would probably freak out a lot. Meanwhile, with numbers, you can do 37 divided by 2, and it will actually work. So you can't do division with strings. So that's an important difference there. And there's a lot of different kinds of data that you can have. So you can have strings, as we said. You can have numbers, as we used as well. We saw a little bit of Booleans, where you could say something is true or false. And there's a bunch of different kinds of things. And not all of them make a copy of themselves exactly like that when you put them in a variable. So things like dictionaries or a list of things, it actually doesn't put the whole thing in the variable. It actually just gives you directions on where to get to it in memory. So that's a really useful thing. If sometime in your future you're using a list and you've made a copy, you think you made a copy of a list, and actually because you've just done it how you might do it with, as we did on our previous slide, with A and B, you're actually going to be pointing to the same thing when you set something up like this. It's not going to be a copy. So we'll cover that more in a later month. There's so many interesting things, but there's just some of the tiny little bits and pieces that if you could just hear it now, maybe it will stick with you for when it possibly goes wrong in your future. But I'm here to help you out with that. So thank you all for coming along to the first episode of In the Code Garden. Next week, we'll be covering making decisions with Python in our branching episode. Sign up on the website here, which Sarah has put in the chat. and also get the resources from today. So there's a bunch of useful stuff you can do on Microsoft Learn for either installing Visual Studio Code and installing the Python extension, or also getting some just more practice on the modules that are on Learn that you can follow along with. So that is all we've got for today. I can't wait to work with you again next week.
Great. Thank you so much, Renee, and thank you for that intro for this week. Thank you to everybody for tuning in as well. Hopefully you will see we've got a registration page up for next week as well. So you can click on that one there, which Renee's put up on the screen, but the clickable version is there in the chat for you. So that's all we have time for today. So we'll leave it there question-wise. We'll see you next week, and thank you for tuning in. Have a good rest of your afternoon, evening, or morning, and see you next time for another Microsoft Reactor live stream event.
Thank you, everybody, and please do the survey if you can in the chat, and I'll see you next week. Thank you so much for talking to me in the comments.